All right, so this is for Module 10. For Module 10, in addition to the PowerPoint slides, I recommend you read the book. In the book, the sections 6.3 and 6.4, there are some examples in there that will help you with assignment. So in addition to the slides, you should read those sections. Just like a typical section, it's going to be a lot of reading. So I'll post it. I have this slides posted, so I'll have you read the slides. It's mostly repeat of what's in the section 6.3 and 6.4. So I'm going to cover a few things from here. The first one is you'll be learning about two algorithms here. One is called a brute force, and the other one is the nearest neighbor algorithm. So there's not much to brute force algorithm. Basically, you just got to make a list of all possible Hamilton circuits. And then for each tour, you calculate the weights, so add up the weights. And then choose the optimal tour, meaning the cheapest tour there is. And there's always more than one optimal tour to choose from. So I'll do an example about that a little bit later. The next algorithm you're going to be learning in this section is the nearest neighbor algorithm. And so the way it works is, let's see, there's a slide for that. Oh, maybe not. Let's see, there's a second slide here. Probably rolling your eyes, giving you a headache here. So here it is. So the second algorithm is the nearest neighbor algorithm. Basically what you do is you start at any designated starting vertex. If you don't have one, if the problem doesn't tell you, just pick one. And the next step is you pick the nearest neighbor, meaning the smallest weight, so shortest distance or cheapest route, or whatever it is. So I'll do the example of this right now. Okay. Oh, and the middle steps is that from each vertex, so you pick the cheapest one from one vertex to the next one, and then when you reach the next vertex, again, you pick the next cheapest neighbor or the nearest neighbor. And if there's more than one nearest neighbor, so the same price or something, like they just randomly pick one. And then for the last step, from the last vertex, you return to the original vertex. So you always have to go back to the original vertex. Okay. So more reading. So here's an example. This comes from the book, and then it comes from the example 6.1. I think his name is Willie, and he wants to take the optimal tour. Say he is limited to starting at vertex A. Then we have A to pick from. So here you can go to A to E, A to D, A to C, or A to B. So the shortest one, the cheapest route is C, AC. So you go from A to C. And then from here, you can go to E, B, D. And as you can see, C to E is the cheapest route, $120. So just keep doing that, and then you get the route A, C, E, D, B, A with the total cost of $773. So from A to C, it's going to be $119. C to E, it's going to be $120. E to D, it's going to be $199. And then D to B, it's going to be $150, and back to A, so that's $185. Add those up, you get a total of $773. But that's not the only one. If you're allowed to start from B, then you can go from B to C. So B to C, A, E, D, B. Oops, sorry. Yeah, back to B. And then if you add up all that costs, then you get a total cost of $722. So that's better than the other one. Okay. So to look at in the exact numbers here, so from B, to C, that's 121. C to A, that's 119. A to E, that's 133. E to D, that's 199. And back to B, which is 150. So if you start from B, the total cost would be 722. Right? Then you can do the same thing starting at C, D, or E. And so if you start from C, and you get CAEDBC, so CAEDBC, and I'm not going to do that for you, but you should go back to the slides up here, this picture here, and then make sure that's the cheapest route, and then add up all the cost. Make sure you get $722. If you do the same thing for D, you get a total cost of 722, and then you start from E. You get a total cost of 741. So 722 seems to be the cheapest route. Okay. Since for the Willie situation, he needs to start from A. You pick the route A, E, D, B, C, A, and you add up all the costs. You get a total cost of 722. Okay, so it's a little bit tedious, but that's how you do it. Just pick all available cheapest routes from any vertex, add them all up, and find the cheapest one. Okay, in summary, here's a summary. Start from any vertex, find the nearest neighbor, meaning the cheapest route, starting with X as the vertex, and calculate the cost of the tour. You just repeat the process with each of the other vertices and of the graph as the starting vertex. And then once you map out all the routes, the tours, you just pick the one with the least cost. Okay? So those are the two algorithms. Two of those you need to know. So back to the assignment. Okay. So here's an assignment. Here's your assignment. First question asks you, use the brute force algorithm to find the Hamilton circuit starting at vertex C. So for you, you have to start from C. But let's say for me, I'm going to start from A. Okay, so if I start from A, I can do A, B, C, D, E. Or sorry, A, B, C, D back to A. That would be 13 plus 8 plus 15 plus 5, which will be, let's see, 13 plus 8 plus 15 plus 5. That would be 41. I could do, let's see, A, C, B, D, A, for example, A, C, B, D, A. And that would be 10 plus 8 plus 14 plus 5. All right, A to C, B, D, back to A. So this will be 10 plus 8 plus 14 plus 5, which is 37. So there are a few other ones, but between these two, I'll pick this as my circuit. Okay. So let's see if I can highlight this. Okay, so that's what you would do. List all the possible circuits and then pick the cheapest one. All right, so number 2, it's pretty easy. You only know 2 algorithms, either the brute force or the nearest neighbor. So read the problem and then see which one you think is the right one to pick for the number 2. You only have 2 choices. So number 3 is the nearest neighbor tour. And you're restricted to start from New York City. So as an example, let's say I start from Shanghai. Shanghai. Okay. Then what I would do is look at the row for Shanghai. So to New York, that's 7,400. To London, that's 5,715. To Istanbul, it's 4,960. Moscow, 4,235. And then Buenos Aires, 12,200. So I'm going to go to Moscow next because that's the cheapest one. Okay, Moscow. And I look at the Moscow route. So between these, I'm not going to go back to Istanbul. So I'm going to go either New York, London, Shanghai, or Buenos Aires. So between Moscow and the other cities, except Shanghai, it looks like I go to London. So London. Then I look at the London row. So New York 3470. Istanbul 1555, Moscow, we're going to skip that, and Buenos Aires 6920. So of the remaining cities, it looks like Istanbul is the cheapest. Istanbul. So I'm at Istanbul. So from there, I can go to New York, or let's see, Istanbul, New York, or Buenos Aires. It looks like New York is the next cheapest one. So New York. Then when I'm in New York, the only place I can go to is Buenos Aires. So, and then back to Shanghai. Okay. So that's how you find the nearest neighbor tour if I were to start from Shanghai. Just look at the row, pick the cheapest airfare, go to that city, and then from that city, pick from that city, pick the cheapest route and just map it out like this. So that's how you do problem number 3. And that's all I have for this module. So if you have any questions, you can always email me and I'll write you back.